Okay, hopefully you read about the two types of errors. So we've been saying it all along, but just to be even more clear about why these errors exist and why we need to talk about them, it's all about having enough evidence. We're not actually coming to any kind of realization or proof. Okay, so either we have enough evidence to reject or we don't. But at the end of the day, we don't actually know if we got it right. Kind of like in a jury trial. So either the jury has enough evidence to feel very confident that this person is guilty, or they don't have the evidence to say that they're guilty. But they're never going to know if they actually got it right. Even if they have a lot of evidence to say guilty, there's a chance that the person didn't really do it, right? And even probably what's more likely is what happens more often is that the person did really do it, but for whatever reason there wasn't the evidence there to uh, to really convince anybody beyond reasonable doubt. They say so. Same things going on here. We come to a conclusion to reject or fail to reject, but the truth is we don't really know if we got it right. Hence the two types of errors. So the type 1 error, hopefully you read it before, but here it is. The null hypothesis is true, but it ends up being rejected. And so we got it wrong. The type 2 error, the null hypothesis is false, but is not rejected. Got it wrong again that way. Yeah, okay. So then you read the example about Frank and his rock climbing equipment. These examples, these problems with the types of error, it's always life and death. It's because we're really trying to make it crystal clear and really drive home a point as to like which error is worse, that sort of thing. So let's look at number 6. A patient arrives at an emergency room in critical condition and is unresponsive. Okay, very serious situation. The null hypothesis is taken to be the patient is alive upon arrival. And there I've got it on the screen. I think that's a good position for the hospital to take. Let's assume that the patient is alive, and we need a lot of evidence otherwise. Okay. So, part A, what is the alternative hypothesis? So the alternative is just going to be the opposite of the null. Uh, the patient is not alive. So you might have been thinking to say the patient is dead, and I think that's probably pretty reasonable. Probably make a good case for that. Generally, though, when we're dealing with logic, we just like to throw the word not in there. So the opposite of alive is not alive. Um, and I think in this case, not alive and dead, you know, get, pretty well opposites. But maybe somebody else would say, no, alive and dead are not quite opposites. Maybe there's other things that could not be alive. Anyway, I'm just going to play it safe and say the patient is not alive. Okay. So really, what we're getting at is part B. Which type of error has greater consequences? So what we'll need to do is look at both types of error and then decide, yeah, I think if this one happened, that would probably be worse. So what are they? All right, the type 1 error. Here's a good way to remember it because it gets confusing. The type 1 error is when this is true, the first one is true, type 1, the first one is true, but we end up deciding the other way. Okay, so in this case, the type 1 error, the patient really is alive, but is decided to not be alive. Okay. That wouldn't be a good situation. They really are alive, but they're decided not to be. The type 2 error is when the second one is true, but it turns out that's wrong. Or that it's decided the other way, I should say. So the type 2 error here, the patient really is not alive. They're not, but they're decided to be alive. They're decided to be the opposite. Okay, so there's your type 2 error. So type 1 error, the first hypothesis is true, but it's decided opposite. Type 2 error, the second one is true, but it's decided the opposite. Okay. So you're going to have homework questions just picking the errors correctly, that sort of thing. But now where this is going, which one has greater consequences? Now they both have consequences, negative consequences, but which one is worse? Is it that the patient is alive but is decided not to be alive? Well, if they're decided not to be alive, then the doctors are going to move on, right? So they're going to go on to other people who need their help. They're going to leave this person, and maybe they could have really helped them, and then they end up not making it. That would be really bad. The type 2 error, let's see, they're not alive, but they're decided to be alive. There are negative consequences here as well. If they are not alive, but they think they are alive, then they're going to spend extra attention on them when they could be putting their resources and their time to other people who still have a chance. So it's not to say there's no consequences here, but I think between the two, type 1 is much worse. And hopefully you guys agree the type 1 error is worse. Okay. When you read that example about Frank, I don't know if you kind of laughed to yourself about how they set up the hypotheses, but I believe they really set them up like the way this problem sets it up. Like this makes sense. Let's assume they're alive. We're going to put a lot of energy in, and if we just can't get around the fact that they're not alive, then we'll move on, but not before that. But in Frank's case, right, he assumed that his rock climbing equipment was safe. And so that led to some problems. Assuming that it's safe, that takes a lot of evidence to show it's not safe, and that could be bad. So I'm going to actually follow this up with, there's this follow-up question here. Just think in general, type 1, type 2. Which type of error is more likely to occur? Because that could really help us in how we frame the null hypothesis in the first place, right? So here we assumed the patient was alive, but with Frank, he assumed his rock climbing equipment was safe. If we can recognize which type of error is more likely to occur, then we can make sure that the greater consequences are the lesser likely to occur, if that makes sense. Well, the way this whole thing is designed, that we assume the null hypothesis, right? We assume 0, takes a lot of evidence to reject. Then which error is more likely? Because they're definitely not equal. Okay. So if you think about that, it's much more likely that the null hypothesis is false, but is not rejected, right? It's much more likely that we end up, because we assume it to be true, it's much more likely that it wasn't really true, but we just don't have the evidence since we're assuming it's true, if you follow me. So here's maybe my reasoning another way that I wrote this time. So the type 2, more likely because we assume that H0 is true. It takes a lot of evidence. Well, okay, I really just wrote the same thing. I didn't realize that. Chances are that we don't reject it when we should. Maybe there's some evidence against, but not enough. But this is a good thing. If the type 2 error is more likely to occur, then let's just set up, every situation where it's the type 1 that has the greater consequences. So if type 2 error occurs, we're not saying there's no consequences, right? Like here, it's not that there's no consequences, but they're far less than if a type 1 error was to occur. That's the worst thing, right? If somebody was innocent but ended up getting, convicted guilty, like that's way worse than if a guilty person goes free. So same idea is in play here. Okay, hopefully that wasn't too confusing. I will see you guys. So much logic in this section. I will see you guys in the Zoom meeting. See you there.